Good day, esteemed judges. I'm Gurakshat,
And I am Arya.
and today we are honored to present our innovative project, the Stubble-Based Bioethanol Production System. We have undertaken this project for two compelling reasons. Firstly, we aim to address the issues of agricultural residue, commonly known as stubble or parali, that is typically burned by farmers in Haryana and Punjab. This practice not only contributes to severe air pollution in states like Delhi, but also possesses environmental challenges. Secondly, we are presenting this project because it offers a sustainable source of energy.
To illustrate this concept, we have used specific materials. Our containers, as you can see, are a volumetric flask and a round bottom flask, which are designed to hold the agriculture residue and facilitate the production of bioethanol. The heat source we have chosen is a candle, which helps to accelerate the fermentation process.
For the agricultural residue, we have collected a sample of rice stubble and additional residue from our recent educational visit to Sundar Nursery. It is essential to demonstrate the effectiveness of our system using real agricultural waste.
Now let's take you through the step-by-step process of stubble-based bioethanol production system.
Now, as you can see, our first step is container setup. So we have two containers. First is our 2-liter volumetric flask, and the second one is our round bottom flask. So we'll make use of both of these. We'll take our volumetric flask and add our rice stubble to it. So for the successful conduction of this project, we'll add water, but not excess water and not too less water. Now carefully the water has been added. Now we'll seal this container with a cork that is connected to a balloon. Now whenever the CO2 or any excess gas will exit, this balloon will inflate. Now in the meantime, the fermentation process is taking place. We will prepare a different solution, that is sugar, yeast and water solution, which will facilitate the fermentation of this container. So in a separate beaker, we have taken our sugar, that is desi khand. This is our dry yeast, and we'll add some water and we'll stir it with a pencil. Well, we didn't mean to stir it with a pencil, but that's what we got. I think that's enough. Now we'll again open our cork and add the solution to our agricultural residue. Now theoretically, this should speed up the process of fermentation inside our container and the balloon should inflate. So we'll seal the cork again, and to speed up the process of fermentation, we will use a candle as a heat source. We are aware that fermentation is a slow process, so by the time fermentation takes place in this container, we'll carry out the same process in our round bottom flask, but with our agricultural residue instead of the rice stubble. Now this we collected from the Sundar Nursery from our recent educational trip that our school conducted. So we'll add this residue to our container first. Now we'll again carry out the same process. We'll add our sugar and yeast solution that is freshly made to our agricultural residue. So after waiting half an hour, we can observe that to some extent CO2 has been collected in our gas containers, or in simple words, our balloons. This proves that beneath these containers, the liquid that is forming is bioethanol, and we can use it for mechanical purposes. and the CO2 that is being released is also usable. We can use the CO2 in many industries, also for the production of many chemicals, and even our favorite aerated drinks is production. What truly sets our project apart is its ability of addressing two crucial issues simultaneously: stubble management and sustainable energy production. By using agricultural residue, we not only effectively manage waste, mitigating air pollution, but also actively contribute to the production of clean and renewable source of energy, that is bioethanol.
In conclusion, the stubble-based bioethanol production system is a forward-thinking project that aligns perfectly with the theme of science and technology for society.
With this, we conclude our presentation. Thank you.